Hi, everyone. Today we're going to review some roots and fractional exponents. First, starting out with roots. So if I have something like the square root of 16, what that is asking is what number times itself gets you 16, right? And of course, that would be either 4 or -4. We're just going to say 4 for now because 4 times 4 is 16. That's why the root of 25 is 5, and on and on and on. We also have these things called cube roots. So like the cube root of 27 is 3, because it's asking what number times itself 3 times, instead of like these, where it's asking what number times itself twice. What number times itself 3 times gets you 27? Well, that's going to be 3 or -3, I suppose. Actually, in this case, not -3, because -3 times -3 times -3 will come out negative. So that would be this. The cube root of -27 is -3. I suppose we should mention that the cube root of the square root of -25 does not exist, at least until we get to Algebra II, because two negatives, when they multiply together, will make a positive, and two positives will also make a positive. So there is no number that when you times it by itself gets you -25, at least in the real numbers, the numbers that we use in Algebra. Reviewing roots again, if you have the root of 144, and let's say you don't know what the root of 144 is, what you can do is you can break this root down and think of this problem differently. And again, that's one of the things we really want to work on in Algebra 1, is thinking of problems differently, seeing the problem differently until it makes sense. That's the whole point of algebra, is to view things differently. So if I think of this as like, I don't know, I see it's, I could write it as 2 times something or 4 times something. I think what I'll do is I'll do it 2 times something. And this is clearly at least 2 times 50, because that gets us 100. And then 2 times 22 would get us 44, right? So 50 gets us 100, 22 gets us 44. So altogether, 2 times 72. And that makes sense. 2 times 70 is 140. 2 times 2 is 4, so 144. I can continue breaking this down until I get into what's called the prime factorization. And a prime factorization is just a factorization that is made up of only prime numbers. So right now, this is a factorization of 144 because I have 2 factors, 2 and 72, right? Factors mean multiplying. So that's a factorization, but it's not the prime factorization because 72 is not prime. I can rewrite 72 as 2 times 36. And by now, you might notice that I can rewrite 36 as 6 times 6. And I can rewrite 6's as 2 times 3 and 2 times 3. So this is all the same number. This is 2 times 2 times 2 times 3 times 2 times 3 is 144. And I can't break it down any further because it's made up of prime numbers, numbers that are only have factors of 1 in themselves. And so now I can see that I've got 1, 2, 3, 4 2's and 2 3's. I can regroup that. Looks like I can do a group of 2's and 3's and a group of 2's and 3's. So if I regroup it like this, I think you'll see it more easily. What number times itself gets me this number? Well, it looks like this number times itself would get me 144. And what is this number? It looks like 4 times 3, 12. So 12 times 12 gets me 144. And this relates to our fractional exponents that we've been working on lately. Because if you have 144 to the half power, it's asking the same thing. And the way we explored this in class, again, this is not how you solve a problem like this. This is just us thinking about the problem differently. If I were to square this number, I clearly get 144, right? These multiply together. 2 times a half is 1, so I get 144 to the first power. And of course, anything to the first power is just itself. So this is 144, clearly. So what this question is asking is, what number do I square to get 144? So let me rewrite that question again. This is the question we're really interested in answering. What number squared gets me 144? This is what this is asking, which of course is exactly what this is asking, right? What number squared gets me 144? And we said it was 12. And that'll be our answer here. So roots and half powers are the exact same thing. This and this mean the exact same thing. And the cube root of 27 up here could be rewritten as 27 to the 1/3 power. So that bottom number in the fractional exponent kind of tells us what kind of root we're doing, right? This is a square root because there's a 2 in the bottom, whereas this is a cube root because there's a 3 in the bottom. I could have a number like 64 to the 1/4 power. And of course, that's the same thing as the 4th root of 64. What number times itself 4 times gets you 64? And I think I just chose a terrible example. 4 times 4 is 16. Yeah, I want cube root for 64. Let's try a better example. This actually doesn't come out nicely. Let's do 81. The 4th root of 81 is the same thing as the 4th power. Oops. 4th power of 81. And that, of course, is going to be 3. Because if I break this down, I can write it as 9 times 9. And of course, 9 times 9 is 3 times 3 times 3 times 3. And so it looks like what number times itself gets you this number? Well, 3 times itself 4 times gets you this number. So that's a little bit of fractional exponents. That's a little bit of roots review. And then I want to get into what happens when we have a fractional exponent like this. So if I have 23 to the 5/3, or 27 to the 5/3 power, what this is saying is this. And we know this from how exponents work, right? This will multiply. 5 times 1/3 is 5/3, right? So these are the same thing. And I think it's easier to think of this. This means what number times itself 3 times gets me 27. So what times itself 3 times gets me 27? Well, of course, 3. This is equal to 3. Again, we're not dividing by 1/3 or anything like that. It's asking what number times itself this many times gets me 27. 3 times 3 times 3 is 27. So then we take that to the 5th, which of course just means this. So 3 to the 4th power is 81. So 3 to the 5th is 81 times 3. It's going to end in a 3. And then 8 times 3 is 24. So 243. So that's fractional exponents. If you have something like this, you can do the bottom part first. 3rd power, right? 1/3. That's asking how many times, what number times itself this many times gets you to this number, right? And then this number is just like a regular exponent, right? Take it to the 5th power. So you can always break it down like that, doing it in any order you want. You can do 5th power first, 3rd power first, whatever you'd like. And that's it for this week.